Hello everyone. So today we are here with another part of integration, which is definite integral. Okay, so till now we were doing indefinite integral. So now this is the part one for definite integral, and we will be taking the questions from R.D Sharma for the applied maths, right? So this is part one for definite integral. So now here the important point is definite integral has a limits. So how do we define it? Everything we will tell you from the scratch so that if you are doing it for the first time, it will be easy for you to understand. Now the important part is definite integral is used in application of integral. So this is very important concept. Without definite integral, you cannot do applications of integration. So that is why this is very, very important. Okay, so let's start with the basics. And as I just said, we will be taking the questions from R.D. Sharma for applied maths, right? So now here, this is the first question. But before moving on to this, as I said, we'll be taking in scratch. That is, how do we calculate definite integral? What does it mean? So let me guide you for that. Suppose you have an integral. I'll just take an example. So example, this is the example, but we will take one more example in terms of the variables now so that you can understand it. So a to b. Now what is this a? A is known as lower limit. What is b? B is upper limit. Okay. So what does it mean lower limit, upper limit here? So here upper limit and lower limit means that you are given some boundaries within which you have to calculate the area of the given function of the given curve, right? So area under the curve you are calculating using definite integral. That is the basic application of integration as well. Suppose I give you a curve and I say कि now find the area from here to here. पूरा area नहीं निकालना है, आपको सिर्फ area निकालना है A से B तक. So your lower limit is A and your upper limit is B. So that is what we mean by definite integral. That is, you have the boundaries with you. Correct? So A to B, this is how we spell it out. So from lower limit to upper limit, right? And you have the function fx dx. So as such, no difference in finding the integration. You will calculate the integration in the same way as you do. Suppose we have 1 upon root x. So in the given question 4 to 9. So 4 is what? 4 is your lower limit and 9 is your upper limit. And 1 upon root x is your fx. Simple सा question है. Now, how to integrate it? If you have the definite integrals, that is, you have the limits given to you. So, for integrating that is a very simple thing that you have to integrate in a regular ways. That is, you will find the integration of the given function. Then, what about the limits? How to use it? That's the second step. So now 1 upon root x का integration कैसे calculate करते हैं आप? You calculate it with the formula of the power rule of integration, right? Which is x raised to n dx क्या होता है? X raised to n plus 1 upon n plus 1. Correct? Now here the power will become what? 4 to 9 x raised to minus half dx. Now if I calculate it, I'll not put any integration sign anymore. So minus half plus 1, minus half plus 1, right? And now you have the limits from 4 to 9. Okay. Now what you have to do, no c will come here because now you have the exact boundary, so no constant needed. Okay, now what will you get? Half, and here also you get half. 4 to 9. You can put the brackets also for the limits, or you can simply show a vertical line also with the limits. Now, what to do after this? Now, after this, whatever integration you have got for the function, upper limit ka value you will put minus lower limit ka value. That is FB minus FA you have to do. So, for the given question, what you have to do is 9 raised to half minus 4 raised to half. This is what you are supposed to calculate. Correct? So now simply this is known as, this is a very, very important thing in calculus, and this is known as fundamental theorem of integral calculus. It's very, very important. This is known as fundamental theorem of integral calculus. Correct? So simply what you are doing, I repeat everything again. So by fundamental theorem of integral calculus, if you have to integrate from a to b fx dx, then you integrate it in the same way as you do for indefinite integral. Now according to that, now what you have to do, value of the integral from b, that is f of b, minus value of the integral at lower limit, that is f of a. You have to subtract both of them, f of b minus f of a. That is what you have to do. So here also we have done. Now let's find out our final answer. So 2 will go up, 9 raised to half is 3, and here 2 will go up, 4 raised to half is 2, so we get 6 minus 4, so our answer is 2. Simple concept, very simple concept. The only thing is what you have to do, upper limit पे क्या value है minus lower limit पे क्या value है, and that gives you the definite integral का value. Okay, now this was the first question from the exercise. Now let's try to take other questions to make you more clearer. Okay, now let's move on to the next. Now here we have minus 2 to 3, 1 upon x plus 7. Okay, now first just think how to integrate 1 upon x plus 7. That's a very simple question. Now who will tell me how will you do it? So 1 upon x का integral क्या होता है, log x होता है. Very good. So now you have to integrate 1 upon x plus 7. So how will you integrate 1 upon x plus 7? Log x plus 7 simply, and now you put up the limits, minus 2 to 3, correct? Now I simply write how we have done it. 1 upon x ka integral is log x, but here no c will come. Now first I will put 3 value here, so what will you get? Log of 10 minus, if I put minus 2 here, what will you get? Log of 5. So what will you get? If I apply the property of log 10 upon log 5, that is log 2. You don't need to see the table or anything for this. If they provide you the value of log 2, put it, otherwise leave your answer here, right? So I just repeated which property of log we have used. Log a minus log b is what? Log a by b. And in the starting, what we have used? The simple fundamental theorem of integral calculus. F of b minus f of a. That is upper limit. पहले आप put करेंगे, फिर आप lower limit put करेंगे, and then you subtract both of them. Right? So fb minus fa, remember. So this is how do we go with the definite integral. Okay, now let's take the next. Now here the limits are from 2 to 3, x upon x square plus 1. Now just think in mind, first of all, forget about the limits. How will you integrate this? X upon x square plus 1. Right? So for integration, we can do the substitution also. So put x square plus 1 as t. Okay? So 2x dx is dt. So let's do it. Now here the important thing is, see, very important thing. When you are doing the substitution, you are changing your function from x to t. That is what the concept says. Now the limits 2 to 3 were for x. Now you are changing your function to t. So you have to change the limits also. So your limits will be according to t. Correct? So now let's put it when x is 2. Okay, for your substitution, right? Lower limit is 2. So when x is 2, what will be t? T will be 2 square plus 1, that is 5. When x is 3, what will be t? 3 square plus 1 is t, right? So t will be 10. So your limits are to be changed from 2 to 3 to 5 to 10. How do we change it? I repeat again. It varies according to your substitution. Here we have substituted x square plus 1 as t. So we are going to change the limits also accordingly. So now here the question becomes 5 to 10. Okay. And now here it becomes 1 upon 2 dt upon t. Now the advantage of changing the limits. Okay, you can do this question without changing limits also. Advantage of changing the limits is you need not change t again to x to put the limits. Okay, now let's see how. So now here we get on integration log t, and the limits are from 5 to 10. So I will simply substitute the limits directly. I need not put the resubstitution कि हमें x में convert करना है, because now these limits are for t. So what will you get the answer? 1 upon t log 10 minus log 5, right? So what will you get? 1 upon 10. We did it in the previous question also. We use the property of log. So 1 by 2 log 2. This is your answer for the question. So I repeat again, whenever you have for substitution, change the limits for the given variable to the new variable. And how will you change those limits? Simply by putting those upper limit and lower limit values in your substitution and get the new limits. So advantage क्या है उसका? I repeat again everything, that you don't have to resubstitute it. So it becomes very easy for you. Correct? So here the limits were 2 to 3, we changed it to 5 to 10 and directly we did it. We did not change it again to x. Okay, because here numeric answer is there. So no need of resubstitution if you are changing the limits. If you are not changing the limits, you have to do resubstitution and then do it. Okay. Now let's move on to the next. 0 to infinity exponential minus x. Now what's the integral of exponential x? Exponential x, right? So now here we have exponential x, the integral as exponential x. Now for exponential minus x, what will be the integral then? Minus exponential minus x. And here the limits are from 0 to infinity. So what will you get? We will do simply f of b minus f of a using the calculus theorem. So now what will you get? You will get simply 1 upon exponential infinity minus 1 upon exponential 0. Now there are two things related to exponents that we can use here. So what are those two things that we can use here? We can use here simply exponential infinity ka value is simply infinity and exponential 0 is always 1, right? So these two values we can directly use. So we have 1 upon infinity. Infinity I can write 1 upon 0 and here I get 1 upon 1. So here I get minus 0 minus 1. So what will you get the answer as 1? So that's a simple answer that we can get, right? So this is what we have. So we have to keep it in mind that एक्सपोनेंशियल माइनस एक्स है तो उसका इंटीग्रल माइनस एक्सपोनेंशियल माइनस एक्स होगा एंड सेकेंड थिंग इज infinity को we use as 1 upon 0 and exponential infinity is infinity. That is, you are multiplying some number infinite times, so you are going to get a very big number, simply like that, right? Because e ka value is between 2 and 3, you all know 2.7 and all. So now here 2.7, 2.7, 2.7 infinite times अगर आप multiply करेंगे, what will you get? The value of very big number, right? So that is what we have. Now let's move on to the next. Now here we have another question. 0 to 1 limits hai x upon x plus 1. So now what we can do, just think of integration first. So what we can do, we can add and subtract 1 to simplify our function. So now we can get this and now we separate the function into two functions. So limits, yes, will come with both the functions, correct. So this is how we move on. Clear? So now let's do it. So this becomes 1. So the first integral becomes 1 dx and the second is 1 upon x plus 1. Clear? So now here what is the integral of 1? X. So limits are from 0 to 1. Now next one, what will be the integral? Log of x plus 1. Yes, very good. So now here what do we get? 0 to 1. Now again we use the fundamental theorem of integral calculus, that is upper limit minus lower limit. Okay, now let's do it. So first integral may if I apply, what will I get? 1 minus 0. Yes. Second may if I apply, what will I get? I will get log 2 minus log 1. Now, can you tell me what's the value of log 1, students? Yes, that's 0. Very good. So, 1 minus log 2 will be the final answer because log 1 is 0. Correct? So, what do you get? 1 minus log 2. Can there be any other way to write it out? Yes, tell me. Yes, correct. We can do it in the way log e is 1 because we are moving on with the base e here everywhere, so log e will be 1, right? If we don't have anything written, it's always e. So we have on the natural log, so what we can write is log e minus log 2. Now these type of things are important for, see, if you leave the answer 1 minus log 2 in exam, marks will not be deducted, but in mcqs these things help because in mcqs they don't give the option 1 minus log 2, they will give you the option suppose e by 2. So you should not get confused, are we doing something wrong, on from where are you going to get e? So here log e by 2 will be your answer. Otherwise, if you leave your answer 1 minus log 2, that will not be wrong. Correct? You will get full marks in subjective. But MCQs ke liye, these type of things, small things are very, very important. And let's move on to the next. Right? Now, here we have 0 to 1, 1 minus x upon x plus 1. Now, how to do it? It is similar to fifth one only, students, right? So if I simply separate it out, then plus 1 minus 1 again we will have to do and get it. So now if I just do it in a very simple way, if I take minus common, what will I get? X minus 1, x plus 1 dx. Now if I add plus 1 and minus 1, it will be easier for you to make the corrections. Okay, now let's make it. We add and subtract 1. Now 0 to 1, x plus 1 will come in 1, करेक्ट. और दूसरा वाला क्या बन जाएगा? माइनस टू अपॉन एक्स प्लस वन, करेक्ट. नाउ लेट्स सेपरेट इट आउट. कीप थिंग minus thing in mind, okay? Minus minus plus, yes. 2 upon x plus 1 dx, right? So this is what you get. Now we have to simply integrate it now. So here becomes 1. So here we get minus x, limits are from 0 to 1, okay? And here what do we get? 2 log x plus 1, and the limits will be from again 0 to 1. Okay, so definite integral is very easy. It's not anything new you are doing right now. Yes, few properties will be there that will be coming ahead in the other session. So now here we have to simply integrate it. Okay, put the values. Integration is already done. So what will you get here? Minus 1, 0 we will get 0. So here we get 2 log 2. And again for 0 we'll get log 1, which is going to be again what? 0. Okay, so what do you get the answer as? You get the answer as 2 log 2 minus 1. और 2 log 2 को आप क्या लिख सकते हैं? 2 log 2 को आप लिख सकते हैं log 4. So put the bracket, okay? You can't separate 2 minus 1, you cannot subtract. Okay, so we get log 4 also as the answer, bracket में. Okay, why? Because log a raised to b क्या होता है? b log a. So again, MCQ के लिए be particular about all this. You can get different answers in different forms. Don't make yourself confused, right? Questions are easy. The only thing is you have to be clear with the concept. Yes, how we can change the form. Okay, now let's move on to the next. Let's move on. So now if we take this question, we can use by parts here. Okay, so integration by parts we are using. Log x first function, integral of 1 upon x plus 1 whole square dx minus log x derivative, right? I think all of you are aware of all this, correct? So here we get integral of 1 upon x plus 1 whole square dx, and then the whole integral. Okay, so here we end up. Now let's move on. What do you get here? Log x. Now what about the limits? Limits will continue. Okay, we will apply the limits after integration. So here we get x plus 1 raised to minus 1 upon minus 1, and the limits will be from 1 to 3, and log x के साथ भी लगेंगी limits सभी और इसके साथ भी लगेंगी. Now what about the other integral? So we get here 1 upon x as the differentiation of log x, and here we get x plus 1 raised to minus 1 upon minus 1. Clear? So now let's apply the limits here. So minus log 3 upon 4 you get, and then if you put 1, log 1 आ जाएगा, log 1 will be 0, so I'm not writing it. Okay, simply I'm writing 0. Okay, so that's easy. You do not show ki what you get, log 0 upon something or log 1 upon something, not needed. So this will be your answer. Now next, here 0 to 1, 1 to 3 limits आपकी हैं. Now how will you integrate this? So minus minus plus, so 1 to 3, 1 upon x, x plus 1. Now this has to be done with partial fraction now, because we have two factors x and x plus 1. I think you all must be knowing to how to do it, but let's do it in a simple way. So we are going to write the integral as a upon x and b upon x plus 1. So we get a x plus 1 plus bx, and in the denominator we get the LCM of the two. Okay, now we'll compare it with the numerator of the integrals, which is 1. So we will put x as 0, correct? So when we put x as 0, we get a as 1, and when we put x as minus 1, we get minus b as 1, that is b is minus 1. Okay, so values are 1 and minus 1. So if we put it here, what do we get? We get the integral of 1 upon x minus 1 upon x plus 1. So what will you get? Log in main integral. I got, yes, very good. So now what will you get? Minus log 3 by 4. Now here log x ka integral, 1 upon x ka integral is log x, and here we get log of x plus 1, and the values will be 1 to 3. So what will you get the answer as? Let's see. Minus 1 by 4 log 3, then again one more log 3. Log 1 is 0. I'm not writing anywhere log 1, okay? Then minus log 4 and minus plus log 2. Okay? Now 1 minus 1 by 4 log 3 plus log 3 कितना हो जाएगा? Yes, 3 by 4 log 3. 3 by 4 log 3. Minus log 4 plus, and then you get plus log 2. What will you get? I just showed you in the previous one. Log 4 can be written as 2 log 2. So minus 2 log 2 plus log 2. What will you get? Minus log 2. So this will be your final answer. Right? So calculations last step तक करनी है. Whenever you practice the questions for definite integral, practice till last step. And wherever you're getting the value 0, no need to mention anything, students. That's important. Just keep on doing your work properly. Okay? Be confident log 1 is 0 everywhere. I'm omitting that value because log 1 is 0. I'm not writing again and again. Okay? So we are just omitting it. And then we have to simply use. So here we have used partial fraction also and by parts. Both the methods are used in the same question. Right? Now let's move on to the next. Now here how do we do? Let's move on. Now here if I take x inside, what will I get? Now can you remember some theorem or anything? See what we have got. We have got the question like this. Now tell me, any theorem you are reminding of? Yes, that's a very important theorem, exponential x, f of x plus f dash x. If you have two functions in addition such that one is the derivative of the other and exponential x is there outside it. So what is your answer using the theorem? Exponential x fx. So same thing is happening here. Log x is fx and 1 upon x is the differentiation of log x. So using this theorem, we can get the answer directly as exponential x log x, and the limits are from 1 to e. Now let's put it, e raised to e log e minus e raised to 1 log 1. Now what will be your final answer? Log e is 1 and log 1 is 0. So what do you get? E raised to e into 1 minus 0. So what's your answer? E raised to e. That's a simple answer that you can give. But remember the values for the different log constants. Okay? Log 1 is always 0. Log e, because we are going with the natural log, will be 1. Okay, now let's move on. Now 1 to e log x upon x. What can we do? Very simple thing. Yes, we will put log x as t. So 1 upon x dx will be dt. So we will have to change the limits now. Let's do it. So when x is e, so log e is t. So that is 1. And when x is 1, log 1 is t, which is 0. Yes, correct. So we have 0 to 1, t dt. That's it. Simple question. Right? Just check how we have changed the limits. We are changing the limits using the substitution and simply simplify it. Okay. Now in this changing, when you change the limits, it might happen lower limit is coming greater than the upper limit. Let it be. It's fine because you are doing the substitution. It may happen that for the new variable, the same region is coming up with the different limits. Okay. Now let's move on. So what will be the integration? This, and then I have to apply the limits, right? So now let's apply 1 first, because for 0 you are going to get the answer 0. 0 upon anything? 0. So what's your final answer? 1 by 2, right? So that is only answer, right? So these questions are not tough, but they need regular practice, because at the last step, most of the time, you make the mistake. Now, how can you do this? E raised to e square. The limits are in e. Okay, now let's take it. And here we have 1 upon log x minus 1 upon log x whole square. How will you take up the question? Yes? Okay, let's do it. Log x as t, let's take. So x is exponential t. This is the relation in log and exponential, if you all remembered. So now here we have 1 upon x. So dx का वैल्यू क्या हो जाएगा? x dt. And what is the value of x in terms of t? Exponential t dt. So I am going to change the question in a very simple function. Limits we will do right now. Let us change the limits also. So when x is e, t will be what? Log e, that is 1. When x is e square, so what do you get? Log e square is t. So 2 log e is t. So what will be your t? T will be 2. Correct? So now let's move on to the next. So the limits will be 1 to 2. And your function will be now exponential t 1 upon t minus 1 upon t square dt. Just see the substitutions. Dx की जगह we are substituting exponential t dt. That is how we introduce exponential t. And in place of log x, I am substituting t. And in place of log x whole square, I am substituting t square. Now this is easy. Again, it's the use of function or the theorem, okay, that which we used in the previous question as well. So now what do you get here? Exponential t 1 upon t as the answer. Which theorem we have used here? Exponential x fx plus f dash x is always equal to exponential x fx. Here 1 upon t ka derivative is minus 1 upon t square. So plus minus. So if I can write it like this also. Right? So that makes my function. That makes my theorem applicable. So what will you get now? E square by 2 minus e. That will be the final answer, or you can write simply by taking the LCM also. So that is how you get it, right? So both answers are correct. Clear? This is how do we change the function from x to t, and how do we do the substitutions. इसीलिए if you do resubstitution is lengthier, इसलिए limits को change करिए. Make the habit every time you are going to change the limit. Okay, so go according to that. Now let's move on to the next. Now here we have x plus 3 upon x plus 2. So again it is a question of partial fraction. Okay, so let's do the partial fraction here. So here the function is x plus 3 upon x plus 2. So if I do the partial fraction, how will you get it? A upon x and b upon x plus 2. X plus 2 will come with a, with b x will come, and here in the denominator x plus 2 will come. Now we will compare the values of the numerators, okay, because denominators are same. Now when x is 0, put 0 as x on both the sides, numerator on the left side and numerator on the right side. So what will you get? 3 is equal to 2a. So a ka value is 3 by 2. Now what will be the value of b? Let's put the other 0, minus 2. So minus 2 plus 3, that is 1. And there we get minus 2b. So what is b? Minus 1 by 2. So a and b we are getting. Let's put it in our question. Now 1 to 2. Okay. So a upon x, we get 3 by 2 upon x. The other one is 1 to 2 again. Minus 1 by 2. Now one line answer. So 3 by 2 log x. And the limits are from 1 to 2. and the other is minus 1 by 2 log of x plus 2, and the limits are from 1 to 2 again. Now let's make it. How do you get the final answer? So here we get 3 by 2 log 2. Log 1 is again 0. I am not putting it. Minus 1 by 2 log 4. Now, see here, if we do it, what will I get? I will get 3 by 2 log 2 minus half log 4. And here already minus sign is there. Minus minus plus will come log 3. 3 by 2 log 2 minus half. And here we can write 2 log 2 for 4 plus half log 3. So 3 by 2 minus 1 is half log 2 plus half log 3. So use the property of log again. Log 2 plus log 3. So what will you get? Log AB. So which is half log 6. That's your final answer. So this is how we take up the question of partial fraction. Limits will come at last. Don't worry about the limits. You keep on integrating. Your concepts of integration are to be applied here. Nothing new in this. The only thing is till end you solve it so that you don't get a wrong answer in exam. Otherwise you get confused in the limits. That should not be done. Okay? That's why you need more practice for this. Now let's do the next. Now let's take the next question. So it's limits from 1 to 4, x square plus x upon root of 2x plus 1 whole square. Root of 2x plus 1, right? Root is there with the entire term. Now how will you do it? The degree is greater for the numerator than the denominator. Now for these type of questions, we have to just start and change the values in terms of the other variable. Now let's do it how? So if we take 2x plus 1 as t square, just to remove the root. So 2 dx will become 2t dt, right? So this is what we get. So dx ka value we can easily get, 2 gets cut. So t dt. Now what about x square and x? What will you do with them? Now for those also we'll find the value. So for x, what will be the value? T square minus 1 upon 2, right? Using the substitution. So what will be the value for x square? X square will be t square minus 1 upon 2 whole square, which will be 1 upon 4 t raised to 4 plus 1 minus 2t square. Okay, now we have to use all these values. And one thing more here, because it's a question of definite integral, so we have to change the limits also. So when x is 1, t will be what? When x is 1, what will be t? T will be 3. When x is 4, what will be t? T will be 9. Okay, so this is what we have. Now we will substitute all these values and check for the final answer. Now let's move on with this. Okay, now what we have? So we have here root 3 t ka value, and here the value will be, this is for t, so the value will be here 3, right? Because t square was there. Okay, so this was the value for t and this, right? Now let's move on with this. So we get here root 3 to 3. Clear? So now we have t here, and now we have found the value of x square also. So what we will get? 1 upon 4. Okay, so now t dt, this is the value of dx, so dt gets cut. So 1 upon 4 I have taken out, t raised to 4 plus 1 minus t2 square, और दूसरा value क्या है? t square minus 1 upon 2 with plus sign in between, x square plus x. Let's check. You can solve it separately also. Okay, now let's move it. So root 3, 3. So what do you get? 1 upon 4 t raised to 4 plus 1 minus 2t square, and let's put it 4 with all. Let's make it 1 plus t square by 2 minus 1 by 2. This 2 will get cut. That's why I make it 1. Okay, now let's see. Correct? So now what do you get? 1 by 4 minus half is minus 1 by 4. So it's a simple integral. Now what will you get? The value. So let's move it. So what will you get? T raised to 5 by 5, but 4 is also there. So you put it for 20. Now here 1 by 4 minus so t, and the limits are from root 3 to t. Just simple. Now we will put the limits. So now we have t raised to 5 here, and the limits are from root 3 to 3. Now we have to put the limits carefully and get the answer. So now let's move on with the values. Now what is 3 raised to 5? So 3 raised to 5 upon 20 minus, now we have here 3 by 4, and now we have to put root 3. So what we will get, minus root 3 by 5 upon 20 minus root 3 by 4. This is what the final answer is. Now we can simply simplify it and get the answer. What is 3 raised to 5? 3 raised to 5 will be 243 upon 20 minus 3 by 4. What will be the root 3 raised to 5? Root 3, that is going to be root 3 square is 9, and then you get 5 powers. So what will be 9 into 9 root 3, right? 81. And so 9 root 3 upon 20 and minus root 3 by 4. So this is what we are getting, right? Now let's try to work it out in a simple way. How can we give the answer? So 243 minus 9 is there, minus 9 root 3 is there, right? Now let's put up the values. So what will you get? If I take the 20 LCM, so 243 minus 9 root 3 minus, now 5 set has to be multiplied, 15 minus 15 root 3, right? So what will you get? Now here we get this, and then we can get this. So here we get 5, right? So we get here 4 minus minus plus will come here. Now 243, and here we get 15. 243, and here we get 15. So 243 minus 15 will be how much? We get 8 here, and here we get 23 minus 1, 228 minus 4 root 3 on 20. So if I take 4 common, 57 minus root 3 upon 5. That will be my final answer. 57 minus root 3 upon 5. That will be the final answer. Just check. I write it here neatly. 57 minus root 3 upon 5. That will be the final answer. Okay. So it will be more clearer to all of you. So it's just about the calculations. Now this question was a little bit, you can say you have to think in the starting what we can do. So here we can simply take 2x plus 1 as t square. T square the reason to remove the root, and we see that it will help us in finding the values of x and x square easily. And we have to solve for limits also. 2x plus 1 is equal to t square. So we will get the value of t square first, and then we can take the square roots of it to get the values for t. Clear to all? Right? So this is how we move on with this question. Now let's move on to the next. Now x, 1 minus x raised to 5. So here we will put 1 minus x as t. Now what will be the value of x that we will get from here? X will be 1 minus t. Correct? Now when x is 0, what will be t? So t will be 1. When x is 1, t will be 0. Now this is the question where upper limit is going to be less than lower limit now. Let it be. So we are having the limits from 1 to 0 now, and it will become 1 minus t and t raised to 5. This is how it goes on. Because dx और dt में क्या relation होगा? Minus dx is equal to dt, so one more minus sign will come here. This you can take inside also, keep it outside. Okay. Now, so if I want to take it inside, I can take it t minus 1 t raised to 5 dt. Right now, so t raised to 6 minus t raised to 5, and the limits are from 1 to 0. What is the integration? By power rule, we can simply increase the powers and get it. For 0, no answer, only the answer will be for 1. So what will you get the answer as? Minus will come 1 upon 7 minus 1 upon 6. So the LCM will be 42. So what will you get the final answer? So the final answer will be minus 1 minus 1 upon 42. So what will we get the final answer? Minus 1 upon 42. So that is 1 upon 42. Clear? So this is how do we solve. Now this is a very very important question for boards also, right? X 1 minus x raised to 5. It comes with n also in boards. Okay. Now let's move on to the next. Now x minus 1 whole upon x square into exponential x. Now again we will use it for the theorem. Correct? So what will you get? 1 to 2 exponential x. Now we will separate x upon x square and minus 1 upon x square. We will go with the theorem now. So 1 to 2 exponential x. So what will you get? 1 upon x minus 1 upon x square dx. So what will you get here? You will simply have the theorem here again. Exponential x fx plus f dash x dx. So what will you get? Answer as here exponential x 1 upon x, because 1 upon x is your fx and minus 1 upon x square is the derivative. You can simply write it like this also as we did in the previous question. So what will be our answer? Exponential x 1 upon x, and the limits are from 1 to 2. So now let's put it 2. So exponential 2 upon 2 minus exponential 1 upon 1. So your answer will be exponential 2 by 2 minus e. You can take the LCM also, right? Previous question was different, but the answer was same. Correct? Now let's move on to the next. Now 0 to 1, 1 upon root of x plus 1 minus root of x. So what will you get? 0 to 1. Let's rationalize it to make it more simpler. So we will rationalize it with opposite sign. So what will you get in the, let's rationalize it here so that you are more clearer. So what will you get in the denominator? A plus b, a minus b. So a square minus b square. So no term in the denominator. So it becomes a very, very simple function. It seems to be tough, but by rationalizing it, we get it in a simple way. So here we get it, right? Now we go with the power rule. So x plus 1 raised to 3 by 2 upon 3 by 2. X plus half b 3 by 2, and this also 3 by 2. Okay. So now the limits are from 0 to 1. Again for 0 you will not get any answer. Only for 1 you will get. So solve it seriously, nicely. So 2 by 3. So we get 2 raised to 3 by 2. And here we get 1 raised to 3 by 2. And 1 raised to 3 by 2 is always going to be 1. Okay. For 0 you are not going to get. But here again, minus. If you put 0 here, first term mein, what will you get? Again 1. Correct? So what will be your final answer? This will get cut and this will be the answer. 2, 2 into 3 by 2 by 3. So what will you get? The powers will be added if the bases are same. So what will you get here? And what can you write for 5 by 2? So this will be your final answer. Just check. Now let's move on to the next question. Now just see, we got the answer 4 root 2 by 3. Now let's move on to the next. So what we get? 1 to 2 x upon x plus 1 x plus 2. Now let's do it by partial fraction here. So now let's make the partial fraction x upon x plus 1 x plus 2. So what will you get now? Now we will separate it out, a upon x plus 1 plus b upon x plus 2. Right? So we can write it as a x plus 2. We'll just take the LCM. Okay, now we are doing it in a very simple way, students. We don't have to make the equations or anything. We just have to put the values of zeros. This is the easiest way to solve for the partial fraction, to find the value of constants. Okay, now we put when x is 1 0 क्या होगा हमारे पास -1. So when x is -1, put it -1 on both the sides in place of x. -1 value रखिए. So what will you get? A, directly you get -1. B will be 0. Okay. So now when x is, the other 0 will be from the other factor. So when x is -2, let's put it -2, a will become 0 automatically and b will be -b. So b is 2. So now Our function simply reduces to minus 1 upon x plus 1 plus 2 upon x plus 2. And the limits will remain the same because we have not done any substitution or anything. Okay, let's put it here. Okay, so that we are not confused. Now let's do the integration. So what will you get? Minus log of x plus 1 plus 2 log of x plus 2, right? And therefore it becomes 1 to 2. Now let's put the values. So what will you get? Minus log 3 plus 2 log 4. Be Pay attention, huh? 1 के लिए हम value put करेंगे because now we don't have any log 1. So we will get the values, okay? So minus log 2 plus 2 log 3. Okay? Now let's open the bracket. So what will you get? Minus. So minus 3 log 3. And here we get log 4 को हम क्या लिख सकते हैं? 4 log 2 plus log 2. So what will you get? 4 plus 1, 5. So what will you get the answer? Log 2 raised to 5 minus log 3 raised to 3. So what will be final answer? Log 32 upon 27. This will be the final answer. Just check last steps. These are very important steps. How to use the log. Log के लिए properties याद रखिए. A log B is log B raised to A. Log AB is log A plus log B. So we have to use these properties to get the simplified form of the answer. Especially when you have log in all the terms or in lot of terms. So there we need to simplify our answer. If we don't simplify, yes, half mark will be directed in boards as well. Okay, so be clear with that. Now let's move on to the next. Now here we cannot use the function, the theorem which we have been using previously in other questions because we have exponential 2x. अब उसके लिए क्या करें? Let's put 2x as t. So 2 dx is dt. Correct? Now when x is 1, limits will also change. T will become what? 2. When x is 2, limit will become what? T will become what? 4. Okay? Now let's make it. 2 to 4. 2 dx is dt. So 1 by 2 will come. Now 2x is t we have taken. Okay. So exponential t. Now what is the value of x? T by 2. Okay. What will be the value of x square? Now let's see. X square का value क्या हो जाएगा? T square by 4. Let's put it here. Now we can take 2 common. Now check your result. Now this is a simple function. Just check. Exponential t 1 upon t minus 1 upon t square. How did we do all this? I repeat again everything. We substituted 2x as t. So 2 dx is dt. So 1 upon 2 dt will be dx. Okay. Now when x is 1, t will be 2. When x is 2, t will be 4. Okay. Now x square का value क्या होगा? 2x is dt. X square will be t square upon 4. Now we will make conversions in t for all the terms that have x. So exponential t, 2 by t minus 4 upon 2t square. So now we take 2 common and then we get this. So this is the final answer that we get. 2 raised to 4 exponential. Now I remove the integral also by using the theorem. Which theorem we are using here? Exponential x fx plus f dash x dx. क्या होता है? Simply exponential x fx. So what will you get here? Exponential 4 upon 4 and exponential 2 upon 2. Okay, so that will be your final answer. In fact, here what you can do is you can, what do I say? Take the LCM also for 4 and get your answer. You can take e square by 2 common also and then you can get your answer. Correct? This is how we go with it. E raised to 4 minus 2e square upon 4. That can be your final answer. You can take e square common also and then you can get the answer. Clear? We can write it like this also. This can be the final answer. Clear? So this is how we go on. These questions are to be practiced a lot. They are very important for board exams. Now let's move on to the next. Now here we have to find the value of k. Answer is given to you pi by 16. So first we will simply do the integration. Okay. So what do we have here? Integral from 0 to k. If I take 8 common, what will I get? Pi by 16, right? This is what you have. Now here we have to find the value now. Now here we can use, do you all remember students, spatial integral formula? So 1 by 8. What will be the answer? 1 upon x square plus 1. 1 upon x square plus a square. What is it? It is 1 upon 8 tan inverse x upon a. So what will you get here? So now here we will make a perfect square, that is 1 upon 2 whole square. So now we can apply the formula, that is 1 upon x square plus a square. The integral is 1 upon a tan inverse x upon a. Now this is for trigo especially. So for applied math students, this will not be coming for the exam, but you can do it for just for the sake of knowing yes, this is for the spatial integral formula. Now let's make it. So now this value is given equal to what? Pi by 16. Okay, so now 1 upon 8. So according to this formula, what will be the answer? 2 tan inverse x upon half, right? And the values for the limits will be from 0 to k. Pi by 16 is your equal to. So now what do you get? 1 upon 4 tan inverse 2k minus tan inverse 0. That is equal to pi by 16. So 4 and 16, 4. So tan inverse 0 is 0. So you get tan inverse 2k is pi by 4. So 2k is tan pi by 4, which we know it's 1. So now you get the value of k, right? So what will be the value of k? Will be 1 by 2. So that will be your final answer, right? So this is how do we find the value of the limits, the missing value. So again, these questions are important for MCQs also. So you can directly do these questions, first integrate it and then substitute it. Now let's move on to the next. Now here we get the answer. The 0 to a integral 3x square dx is equal to 8. Now this is very simple question. 0 to a, 3 is constant, x square dx, and the value is given equal to 8. So 3, and here you get x cube by 3, and the limits are from 0 to a, and this is equal to 8. So if you put the values, a cube by 3, 3 gets cancelled, and this is equal to 8. So what will you get? A cube is equal to 8, right? So now what will you get? A cube is equal to 2 cube. So what will be the value of a? A will be 2. So this will be your final answer. So this was the basic introduction to definite integral, right? I hope you all have understood it well. So please like, share and subscribe. Thank you everyone.